All right, welcome new viewers. This is the sprint review session, sprint challenge review session for the GRAPS Sprint Week 6, Lambda School CS24 Tico channel. And here we go. Who's going to be reading the README for us? Tani? Sounds great. Thank you.
You are provided with a pre-generated graph consisting of 500 rooms. You are responsible for filling traversal path with directions that, when walked in order, will visit every room on the map at least once. Open adv.py. There are 4 parts to the provided code. World generation code, do not modify this. Incomplete list of directions. Your task is to fill this with valid traversal directions. Test code. Run the test by typing python3 adv.py in your terminal. REPL code. You can uncomment this and run python3 adv.py to walk around the map. You may find the commands player.currentroom.id, player.currentroom.getExits, and player.travel direction useful. To solve this path, you'll want to construct your own traversal graph. Start in room 0, which contains exits NSWE. Your starting graph should look something like this. So try moving south. You'll find yourself in room 5, which contains exits N, S, and E. You can now fill in some entries in your graph. You know you're done when you have exactly 500 entries, 0 to 499 in your graph, and no question mark in the adjacency dictionaries. To do this, you'll need to write a traversal algorithm that logs the path into traversal path as it walks. Would you like me to read the hints? Sorry.
Actually, yeah, go ahead and read the hints, please.
Right, so there are a few smaller graphs in the file, which you can test your traversal method on before committing to the large graph. You may find these easier to debug. Start by writing an algorithm that picks a random unexplored direction from the player's current room, travels and logs that direction, then loops. This should cause your player to walk a depth-first traversal. When you reach a dead end, i.e. a room with no unexplored paths, walk back to the nearest room that does contain an unexplored path. You can find the path to the shortest unexplored room by using a breadth-first search for a room with a question mark for an exit. If you use the BFS code from the homework, you will need to make a few modifications. 1, instead of searching for a target vertex, you are searching for an exit with a question mark as the value. If an exit has been explored, you can put it in your BFS queue like normal. 2, BFS will return the path as a list of room IDs. You will need to convert this to a list of NSEW directions before you can add it to your traversal path. If all paths have been explored, you're done.
That was a very good narrative voice. Thank you. Okay. So does everybody seem clear on that? I mean, I feel like I would like somebody else to read it in a different voice. Again, just because I hear it twice, it'll just register better for me. But it's up to you guys. If if somebody does understand it very well, please, by all means, like start explaining or summarizing for us, so then everybody can get a better idea of what's going down tomorrow in Chinatown, Sprint Chinatown. Anybody? I just see Obeda back there, like, just like looking out, like, can somebody share a quick summary of what they believe that we have to do tomorrow?
We have to explore every room, and then we're done.
Rooms. How do you have to explore them?
Programmatically.
With the graph.
with the graph. So like what would you be storing? It says here that as you're traversing, you should be storing stuff.
The nodes that the direction takes you to, I guess. So 0 south takes you to 5, so you would put 5 south. You're filling up, you're pretty much changing the question marks to variables.
Correct. And then one thing as well is like, so when you're traversing through, like you're going into a room, right? So you'll be dealing with room IDs, but it says that you need to store not the room ID in your path, because that's what you would normally store. You're actually storing what?
Available exits.
Like a direction, right? Like the direction, yeah. Yeah, so like kind of like a breadcrumb trail, if you will. It'd be like a long list of north, south, east, west directions. Can you go to the code, please, Miss Lopez? And let's like look at this and let's talk about it. So there's line 12 through 17. You got a bunch of different sizes of maps that you can work with. I highly suggest going with a smaller map before you try to traverse the whole maze. So like line 13, the test line.txt. If you can click that and just give us a little preview.
Yeah, I think one of them's only like 3 rooms.
Yeah. Yeah, and that'll make your debugging a whole lot easier for sure. Here's test line. So yep, 3, just a line of rooms. Then you have like your test cross, test loop. And so those are all different. Yeah, it'd just be like a different array of rooms or a different object. Okay. What else we got in that code there? If we head back to adv.py, what else do y'all notice?
Visit of rooms is stored as a set. So
Why do
that'll
you
prevent
think?
duplicates.
Yeah. Yep. So line 28 gives you some instructions. Fill this out with directions to walk. So that's like as you're walking, you are recording these each time, right, into this traversal path. Right here, line 30.
So that's to, we're basically recording where we've been so we kind of know which ways, and then we're actually, like if this was a front end, we'd be putting that data to the front end.
Mm-hmm.
Okay.
Wait, so when they say fill this out with directions to walk, they just mean like line 29. So like you can go north and then maybe you can go east from that room. Like that's literally all.
Yeah, so like let's imagine, like can you scroll up real quick, Jaden? Can you go to that, back to that, actually, you know what, I'm just gonna draw it on here so then we can also see the code too. Okay, so if I'm in room, like let's say this is room, oh, where's my annotate? So this is room 1, right? And then this is room 2, and then you have room 3. Ooh, there's a window in that room. Just close the window. Okay. So let's say you start here in room 1. Like there would be no option to go north, right? No option to go, I almost couldn't remember that direction, west, south. There's only one option to go east, right? And so like you would have a question mark here because it's unexplored. So you go this way. As soon as you go this way, like most times when you traverse the rooms, like what are you recording? You're going to record like the value of the node, right? Or the room. So you normally would record a 1 or 2 or 3 as soon as you walk into the room. But no, they want you to record the direction you took to get into the room. So then this is where this would go into traversal path. So then over time, you've accumulated like this super long list of just like a ton of different steps that you took to get to where you are. or having like traversed through the entire like 500 room maze. Does that make sense?
So if you added a room off of 2, for example, then yeah, for that, for example, and we're doing breadth first, so then we would just do like what, east, east, and then you would add north and east
Yeah.
to your traversal path. So
Yep.
all of that would be like east, east, north, east, all in that one.
Is this array meant to help us out when we're going backwards? Is that the point?
Yep.
What did you say?
So go ahead, Abeda. Repeat what you said.
So this array, I think it's supposed to meant to help us when we're backtracking. So like you're now at like, let's say, you know, north, south, east, and now there's a bunch of question marks that you left behind. You can do like a reverse array and then go back in that same direction. Or I guess the opposite of if you went east and you go west now, and then you have to go north until you hit like a room that there's question marks.
So like, yeah, like if you're starting in room 1, right? And then you go to room 2, and then you go from room 2 to room 3, now you're at a dead end, right? You can't go north, right? There's no south room, there's no east room, right? So what do? You have to refer back to this traversal path. And then because you've already logged all the directions that you've had to make to get to that point, to room 3, then you can just reverse those directions to go backwards, right? You do like they talk about doing BFS, right? To find the shortest room with the question mark available. So like you might have a question mark here. So then it would, you do a BFS to go to here and then to get to here, right? So like that's the kind of the purpose of this traversal path array. Or list, I guess. It's not an array. Array is JavaScript, but okay. Let's see. Let's keep moving down in the code here. Let me delete this stuff. Okay. What else you guys see? What is lines 34 through 47 doing?
So we're recording the rooms we visited in this set. So this is what we're holding those visited rooms in. And then playing current room, I guess this is actually instantiating that we're starting here in this room of the world. And then we're adding the player to visited rooms so that we can show that, okay, this is where the player is starting. So this is your starting point, and add that to visited room set, right?
Yeah, I think that sounds right. Anybody have anything to add to that or agree with that or?
Interesting that it's a set. I would think the visited rooms would contain, well, I guess you could have a set of objects. So yeah, it wouldn't matter. Yeah, so each visited room would basically be like a dictionary that has the room ID with north, south, east, west, and whether or not north, south, east, west has been traversed already.
Yeah. So like, what would the value be then for each of the directions? Like if
if you've already walked through that direction, it would be a question mark, and it would be a room ID, a connecting room, and then if you haven't, it would be a question mark.
Nice. Very good. I'll be right back. Daughter to bed. I'm coming. You're being recorded. Okay, I'll be right there. Keep going, and I'll be back.
I actually have to step off.
Okay. Yeah, if you need to step out, you can. I'm coming. Hey, you're demanding. I'm coming. If you stay, I'll be here when you get back.
I have to go as well. Does somebody want to pull this up?
I also need to drop off. Sorry.
Okay. Brian and Tanya, you guys gonna be the only ones in here, or Brian's got to go too? Tanya's got to go too? I'm
I
coming.
could stay a little longer. I mean,
Okay.
I could use a snack if we want to take a break and come back.
Okay.
I can only be here till 8:30, but go ahead, Brent.
Oh, okay. All right, I'll just stay then.
Yeah, I may or may not stay. I don't know.
Okay.
Actually, I did want to. Yeah.
I gotta hop off. So
yeah, when are you gonna be back
guys,
in 10 minutes?
in like 5 or 10 minutes.
All right, cool.
Probably 5 minutes. I just gotta put her to bed.
All right. Take your time. I feel like Beta was getting very scientific.
I'm still trying to wrap my mind around this a little bit.
It's for tomorrow.
Yeah, let's see. So I guess part 1, is that it? Is it? How do we know if it's part 1? Okay, yeah, I guess this is part 1.
Oh, we should look at by the way, we should look at the matrix if you haven't looked at it. Because remember last
which
week,
file?
Oh no, at the bottom, like the grading matrix.
Oh, the grading rubric?
Yeah. Okay, so there's just we
got to traverse a large graph. So we have to have, it's either.
Okay, so it's just the length of the path.
Yeah, but is this added to the day 2?
That's a good question.
So, because graphs 4 should be something different, right? Oh wait, sorry, that's a recording. We don't need that.
So.
Oh, it's just that one then.
For the sprint, yeah, you just click on like number 6, right?
Yeah, I have it open here.
Okay,
I was just wondering if there was like another.
Yeah.
I think that's it though. Oh, there is. Wait, what? No.
That's the daily.
I'm being crazy.
Okay, yeah.
So yeah, that's it.
Okay, so there's no day 2 rubric.
So it must be within this. So I guess we have 2 days to do it then?
I guess so. Yeah, I guess like.
Right.
We just have to like figure out how to traverse it and then do a better job of it, right? I remember, yeah. My TL, like from a while ago, was doing this one week, and I remember he said that. I think he mentioned like he had to like figure out what kind of search to use, like depending on where he was.
Mm-hmm.
You know what I mean? Like
yeah.
And so not any spoilers, but I think I'm just could be total conjecture, but I think the idea is like to get between 2,000 or under 960 whatever
steps.
Yeah, you have to probably use like different searches at different times. My guess.
Yep. Yeah. So yeah, if you get less than, what is that? Less than 2,000 moves, you get a 2 at the bottom there. The rubric, you get a 2 if you get less than 2,000, or between 960 and 2,000. If you get more, then you just get a 1.
Yeah, we were looking at the grading matrix because like as of last week, we're like, let's just make sure that
Yeah.
concentrate on the right stuff.
Yeah.
So yeah.
What all did you guys go through while I was putting Lucy to bed?
Honestly, just that. And just
Okay.
there's no like day 2 rubric, right?
No. Mm-mm. So your advantage is you have a lot of time. Is there anything you're particularly worried about? Like let's talk about objective. Like if you just had to explain what you're going to be doing to your spouses, like, hey, what are you going to be doing for your sprint challenge tomorrow? Like if you just had to tell them, like, what would you say right now? Tony?
So
Grant?
Sorry, I was chewing. So you're starting in a room,
Mm-hmm.
and you're exploring connecting rooms
Mm-hmm.
by walking
Mm-hmm.
from room to room, I guess.
Mm-hmm.
And you're just keeping track of the directions that you travel to get to the different rooms.
Mm-hmm.
And question marks signify unexplored rooms.
Correct.
So
by keeping track of the steps that you've taken, like how would that get us close to like our solution in the end, like the ultimate thing we're trying to figure out, like according to the rubric? Like what is the rubric looking for?
less steps is better.
Yeah. So you basically just need to do like the fastest, most efficient search in the least amount of steps. So
I'm trying to think of an analogy, like it's kind of reminded me of like Google Maps when they like I don't know, Tony, if you did I feel like I always mispronounce your name. If you looked at the Udemy stuff, but there's an analogy of like Google Maps and like finding the shortest route, like based on all the streets, whatever. It's kind of like that, but it's not really
I was thinking, check
a
this out.
linear route.
I was thinking like, what about like Candyland, or like when you play like a game like Trouble. Remember Trouble? Pop-O-Matic Trouble. It's fun getting into trouble. Like you can like go back spaces, you can go forward, right? And so like keeping track of your moves allows you to go back, so that you don't have to visit rooms that you've already visited if you don't have to. So basically, like you're gonna do a search one way, and then you're gonna do maybe another kind of search back whenever you have to backtrack. But your goal is to find the shortest path to the next question mark from where you dead ended at. That makes sense?
Yes, it does.
Okay. And then Tani, can you, for the camera recording, can you just pronounce your name the correct way, so that way anybody can refer to it on the recording?
Tania.
See, I always thought it was,
Sorry.
dude, I always thought it was like Tanya, because I know like some girls that have the same spelling that they go by Tanya.
Yeah, no, it's 3 syllables. So that's why I go by Tani, because it's the first 2. So it's Tani, Tania.
Tanya. Yeah. Cool.
Yeah.
Okay.
Is it cool though?
It is cool. It is.
Is it?
Yeah, it's cool, man.
I don't know,
like
man.
It's on the recording now forever. So
Look, my dad's being creative, so I've suffered for it my whole life.
I guess, what about the hints? Have we gone over the hints yet? I feel like everybody has a good idea, maybe the high level overview of what you're trying to do, but let's talk about these hints. Brian, you want to read like the first few hints or something, and we can, that way the viewers can also benefit.
Start with a small room,
Mm-hmm.
or a small maze. Write an algorithm that picks a random unexplored direction from the current room, travels and logs that direction, and loops. Okay, so when you reach a dead end,
That should cause your player to walk a depth first traversal. So you can just look at your DFT function, right? And just see what it's doing in that. So you have to implement some sort of like randomization into your algorithm that allows you to explore these rooms in a depth first traversal pattern. Why would you do depth first traversal? Any ideas? Why not have the player walk in a breadth first traversal?
Because you're trying to figure out the connections. So if you, like in your example, when you had like room 1 connects to 2,
Mm-hmm.
which connects to 3 and 4, I guess.
Mm-hmm. Like
yeah,
what
you're
do you
kind of
wanna-
like you're drawing the maze, kind of.
Yeah.
You're find the connections, or you're like, yeah, you're going through each step.
Mm-hmm. What should you automatically think of if you see a code challenge that has the word shortest path in there?
BFS.
Right.
BFS. Yep. Breadth first search. When you hear the words maze and going through a maze, traversing through a maze,
DFS.
DFS or DFT, yeah.
I watched those videos.
Yeah, you know
The
what's up.
pre-lectures.
So depth first traversal, I always remember when we were going over that, Bryant would say like, okay, like if you have these nodes in a tree, like depth first, you're going to go deep first before you go, to these inner nodes over here.
You're scuba diving.
Yeah, scuba diving. Yeah, going deep first, right? So you're coming down here and you're going down there first. And the idea with the rooms though is that you want to go as far as you can until you hit a dead end, right? Just like with depth first traversal, you're gonna go as far as you can until you hit what's that called, a leaf, which doesn't have like a child leaf or whatever, doesn't have any more children. Like you get to the end of the path.
Yes, leaves. Forgot about
Yeah.
this.
So that's why we want to use the depth first traversal inside of like a maze, right? Otherwise, the breadth first traversal would just go like this, and then it would go like this, and then it would go over here, and then down here, and here, and here, and basically just go down level by level. So that's why you end up finding like the shortest path. But you could use that to your advantage in a different for a different part of the traversal, I guess you can say. Maybe when you looking to backtrack. Yeah. Good find. Okay. So then, what else? How do you know when you're done? Like, how do you realize that you've completed all the traversing? Exactly. So how would you do something like this? What do you need to keep track of? What metric are you keeping track of currently right now as you traverse through each room?
Is there?
Steps.
Right? So what could you do with the steps to help you figure out how many rooms you've gone through? Right? Because you start at like we talked about earlier, I'm in room 1, I'm going to room 2, and then here's room 3. I start here in room 1. Let me draw a star there. Okay. I go east, right? Now I'm in room 2. Okay. And then as I'm doing that, I need to record in that traversed array. I need to put on there that I went east. Right? And then if I decide to go east another time, now I'm in this dead end room, this third room over here. I need to put another direction that I've gone in there, right? So I've just walked through 3 rooms, right? So what can this tell me about the number of rooms that I've gone through, this array?
I mean, well, that's really just telling you, that's keeping track of the edges, isn't it? Because you have 3 rooms.
Mm-hmm.
You have your starting room plus the 2 that you've gone east into.
Mm-hmm. Well, actually, you know what? Yeah. So I don't know if you could use this. No, you couldn't, because this would also keep track of backtracking, I believe. Let me see.
I mean, you could like recreate the maze file and do like a key value for what's like the room you've been to.
I mean, you have to make sure there are no question marks left as well.
Right. Right.
So if there are no question marks, then you should be done in theory. Right?
I mean, yeah, that's true. That's true. Do you think it'd be smart though to also make sure that the number of rooms you've reached is 500?
I mean, in a perfect world, yeah. Otherwise, I just go back. I just hand count them, Tico.
That wouldn't be very dry.
I got that. I'll just count them all. No, I mean, it would be good.
Yeah. So actually, from what I'm seeing on here,
so that's what traversal path is for, we know.
So anytime, so I think we talked about this. Why would you use it? Why would you ever use a set?
So that you don't have any duplicates.
If you know that you're going to be traversing through a ton of rooms and you're going to have to backtrack every now and then, it would make sense to use a set versus like a dictionary, right? Because a set is just...
A dictionary can't have duplicates either. Like there can't be 2 keys with the same, they're the same. So like if the key is the room number, there couldn't be 2 5 in dictionary or in a set. Where I see the difference is in.
I mean, you can if it's a hash
value
table with that linked pair, right?
Well, then the key when
collisions, yeah, you'd have collisions actually.
Yeah,
and then you can handle collisions with a dictionary using the linked pairs.
Yeah, I just mean like the most literal sense, like you can't, like in those 2 lines on the top of your screen, like you couldn't have 2 0 objects. But with sets, the main difference I see is like in the value within the set can be like comma separated, and you can access by index, like
Okay.
Key of 0, index 0. That's just the main difference. But
So like basically a set is a dictionary with just the keys, right? And you get the O1 lookup time. And you also get access to set operations, which are specific, right? Like you can do I dropped the link in the channel to the W3 schools, Python sets. Let me see that one. A set is a collection which is unordered and unindexed. They're written with curly brackets. You cannot access items in a set by referring to an index. Since sets are unordered, the items have no index. But you can loop through the set items using a for loop, or you can ask if a specified value is present in the set by using the in keyword, right? Okay. Okay.
You can search through it.
So like if you wanted to, you could have a set that has 3 values in it, three keys, right? It could be like apple, banana, and cherry. And then like you have a for loop and you do for X in this set, right? And then print X. So that means that if X is in that set, then you would print X. Right?
So you could be like you could look like, is there a question mark in like for value in here? Is there a question mark in it? Like in this room, or the stuff in the room, is there a question mark? Is that weird? Like
Tani, can you go back to that? Can you go back to that page that you were just on, please? What Brian was talking about. So if you scroll down a little bit, like they're just checking right here. Like they're checking if banana is in that set, right? Right here. So it's nice because you can just use the in keyword right there. Banana in this set. Check if banana's in there.
So we can put question mark in this set in theory.
Yeah. And it would return true or false, right? Let's see, let's run it. Run it. Why isn't this code running? I don't even see a run button. Do you guys see a run button? Or is it just me?
I don't think it all loaded.
Oh, okay. Oh, there it is. Returns true on the right there. So if it is in the set, it will return true. If it's not, then it'll return false. So you could use that to your advantage when searching for rooms that still have the question marks in them, right? And that's about my time, ladies and gentlemen. Oh, and there's some more methods down there that you can use.
Thank you.
Yeah, thank you.
Yeah, sick. Hey, real quick, what's the point of lecture tomorrow?
I'm not really 100% sure. I wonder if the stuff that he's going to go over is going to be pertinent to the sprint challenge. Let's see, the graph stuff for tomorrow would be the graphs 4 module maze traversal. Oh, okay, so they will go over traversing a large maze tomorrow, I guess, huh?
Okay.
That's what it says on here. right? Because
Or
we went
these
over
sponges.
graphs 3 today. Yeah. So, yeah. Anything else?
No.
No. Yeah. So tomorrow I'm gonna take my wife to the doctor's at like 7, and then hang out there till like I'll find a place to work till like 1, and then come back. So I'll be kind of on and off line for like the commute time and stuff. But
Got you.
yeah.
Got you.
So
No problem, dude. Take care of your wife. I should be back in time. I have my interview phone, like just a phone screen at like 10:30 a.m. Eastern. So class starts at 11 Eastern. So should be done within that 30 minutes though. So
Well, good luck to you.
Yeah.
And
Thank
have
you.
a good appointment, Bryant. I shall go feed my dogs now.
Go have a great time feeding your children.
It'll be wonderful.
Four-legged
They'll be
children.
very pleased.
All right.
Okay.
All
All right,
right.
guys.
See you
Good night,
guys.
Thank you.
guys.